Okay guys, welcome back. Well, now we're going to complete a continuity test of the lead that we made up. We're also going to do an insulation resistance test or an IR test. Now the IR test, you would have already done partly that in the topic skills practice today, but just in case that you are unsure, I'm going to go through the process of how to connect that and how to test that as well. So to do these two tests, we need two different meters. We've got a digital multimeter with the actual multimeter, and we'll put the multimeter on the resistance scale. This is the upside down view, if you like. And we hold it, once we've got it turned on, we make sure that we put the two pins together and we should get a 0 reading. Hold it nice and firmly. It'll float a little bit, but don't be too concerned about that. Some meters have the ability to be out of 0 upon you doing so. Now when you're doing this test, I'll turn it back off again. When you're doing this test, just be conscious of the fact that what we're testing is the continuity, which means the word continuous. Continuity is an adjective of the word continue, and we make sure the conductor is continuous from beginning to end. Now, because you have a plug top and a base, it is difficult to get the end of the multimeter leads into the female end. So what I suggest you do, and I have done this, I've got an empty 3-pin plug connector, plug top, and I'm going to plug that into the end of the 3-pin base. This conductor's a bit bent, I'll just straighten that. Plug that into there, ready to go. So then I have these terminations at the back where I can easily put a multimeter lead into. So remember, I'm only putting 1.5 volts through it on a multimeter, therefore there's no damage voltages to worry about. Okay, so the first thing we'll do, we'll test the meter. I'll get this open like this so you can see it as well with me. Okay, hold the lead together, should be close to 0. Do the earth conductor first. So the earth conductor is the one at the bottom, the silver one, and I'll check the silver one at the other end. And I should get close to 0. The termination is correct. Because, put it on the bolt because the screw's not done up tight, we may have to do that up tight to get a connection. So it might be a pointless to do that first. Do the terminations on the plug top that you've plugged into the female end of the cord. Do those up tight first, because otherwise they'll float a little bit because they're not making good bond. So do those up tight so that there's no movement in the connection when you put the multimeter lead on there. Okay, let's start again. Okay, there we go. So once again, the earth conductor and the earth conductor, and I should get a reading close to 0. And that says it's floating around 0. Yeah, it's pretty constant. That's good. That means there's continuity between the wires at both ends. Okay, now my left conductor is going to be the neutral conductor, which is the blue conductor, and I'm going to go to the blue conductor on the other side. And remember what we said before, looking behind, the active's on the left and neutral's on the right. Looking in front, it's the other way around. So we know that the neutral is on the right hand side. Once again, holding it nice and tight, we should get close to 0, and we do. That's good. And the last conductor to worry about is the active conductor. We do that again, and we hold it nice and firmly, and it should float around 0. And all that's good. We know that all those conductors and all those terminations that I've done on this lead, the wires are continuous in all 3 cases, and that proves that the lead is functional. Okay, that completes the continuity test. Now the insulation resistance test. The insulation resistance tester, we're using this Kabak Mega or IR tester. Just make sure before we start, we're just going to know where to put the actual leads to start with. So we'll start at the back. I always put the red lead in the line termination, and that's the one on the left at the back. And the one on the right at the back is the earth termination, which is the black. get both of those in, get them so that they both face up so it doesn't put any stress on the termination when you put it back down. Put it on a slight angle so you might be able to see that with a bit of luck. I've also screwed the jaws on the end of the conductors, but I'll just go through that with you so you know that you can do that as well. So basically that's how you might find inside the container when you pick it up. Black to back again, and I do this because we're putting a voltage of 250 or 500 volts on the insulation resistance test. I think standard practice for AS3000 has got to be a 500 volt test. So to do that, we don't really want to be touching the end of the pins. Of course, it will give us a little shock. Not dangerous or anything like that, but not very nice to feel. So once again, I'll start with the earth conductor. With my black lead, I'll put that onto there. Now, I may not be able to get the jaws on this end, so what I might just do, I will take the active jaw off now, and that's all off as you can see already, so be careful with this. Put that on there. Now, I want to make sure that my meter is on the 500 volt test, which is here, so generally it might be found there, or even far right, which is the 1000 volt test. The middle of the red settings is the 500 volt test. Now, if I tested it now, nothing would happen, nothing would read, because I haven't actually turned it on yet. So to turn it on, you push this yellow button down and you turn it clockwise, and you see the red LED flashing in the middle of the screen. So if I do a dead short now at 500 volt test, I'll go full scale to the right hand side, which basically means there's zero resistance. And if I go between earth and active, I should get infinite. The needle hasn't moved, which basically means it's open circuit, and that's how it should be. I go to the neutral conductor, it should be the same test again, and it should also be open circuit. I just test my meter again to prove that the meter is working okay. Back to the earth conductor, and once again, it's a dead short, goes far to the right hand side, you know that's okay. Now we go to the other end of the lead, just make sure there's no issues there. We'll go to the earth conductor again, we should get a dead short, we did, far right. So we'll go to the active conductor, should be open circuit, and it is. We test the earth conductor again, just to press the meter once again. Dead short, correct, and then we go to the neutral conductor. And once again, it's open circuit, as it should be. Test the earth conductor again, it's okay. Turn the meter off before we play with the leads again. And now we're free to actually disconnect. Okay, that's the insulation resistance test. We've now proven that this lead is now tightly functional. There are no shorts. It's ready for use. The only thing it's missing now is a tag. If you were licensed, you'd be able to put a tag on it saying that this lead is safe to use by anybody. Thank you.